Good afternoon and welcome back to NASA's Johnson Space Center for our post-mission management team meeting briefing. This is the flight day 3 of the STS-134 space shuttle mission to the International Space Station. So for the briefing, we have opening comments from Leroy Kane, who was the chairman of the MMT meeting and also is the deputy program manager for the space shuttle. And then we'll take questions. Leroy?
Thank you, Kylie. It's good to be back with you today. We've had another spectacular day on orbit with the Endeavour and crew. I know you've been briefed on the rendezvous and docking, which was flawless and went very well. The crew got on after that with the express logistics carrier operations, and all of that went very well also. And they rounded out their day with some other activities that were on the timeline. They're sleeping now on orbit. The shuttle crew is sleeping. And so things have gone really well since we were last here, and the vehicle continues to perform very well as well. In the MMT today, we had a couple of items to talk about, and I'll just briefly mention a few of those. We did get all of the RPM photos on the ground, and so the team has been poring over that data, and we have a good bit of that assessment to complete yet. But they brought in a status of that, and I'll get to that in a minute. The wing leading edge system that you're aware of that we use primarily for ascent to give us any indications of impacts. We turn that on periodically when we're on orbit, and the team reported we didn't have any reportable items from any of the on-orbit monitoring periods that it's been on so far. So that was summarized today as well. The next time that system will be active will be during the Soyuz undock activity on Monday, currently scheduled on Monday. The leading edge support system, the reinforced carbon-carbon team, looked at all of their data from the Flight Day 2 inspections and all of the other imagery and data that they have to look at and analyze, and they've determined that they don't have any regions of interest where we need to go look at any more detail. And so we've essentially cleared the wing leading edge, and they were able to brief us on that today as well. Where other imagery and assets are concerned, we're making good progress on the SRBs, and they'll be doing open assessment here in the next 24 hours, and we expect to get some video by about this time tomorrow. If not sooner, the video will be on the servers for the solid rocket booster videos, and so we look forward to that. The team came in and did the ascent quick look today. That's where we do a very high-level overview of all of the various parameters from the launch and the ascent and the vehicle performance, to include the day of launch ILOD assessment, guidance, navigation, and control performance, the loads, the aero, the thermal, and they briefed us on that, and that quick look assessment, the vehicle performance was very, very good. No issues or concerns. Nothing poking out there that we have to talk about. So we got a good summary from the rest of the team on a few very minor systems issues, and there isn't anything there that's going to be any impact to the mission. They're very minor problems, and so they'll continue to work through those if necessary. The other status we got today was from the TILE team, the damage assessment team, the DAT as we refer to them. They came in and they gave us their assessment of where they are in looking at all the photo data, the photography data from the RPM, really all of the data that we have in-house as of now. And we have a few charts that I can show you to sort of summarize where we are as of now. If we have them available, Kylie, we can show the first chart. This chart just shows the bottom of the orbiter, obviously, in this graphic. There are 3 boxes that are in yellow, and those are areas that we need to get. All of these areas, I should say at the front, we're not finished assessing. We're in the process of assessing these areas as well as some others. But these were ones of interest that the team wanted to show us today, and so we talked about them. The ones in the yellow box are the ones that are at least initially of greater interest to us than the other ones. And so I think we have a couple of charts to show you some more detail of the ones in yellow. So we could go to that next first chart. So in this site here, it's just a little bit more detailed close-up view. And you can see where the white areas where we're missing the outer coating and perhaps more than that of the tile. And this is one of the areas that the team is going to do some more work on to determine whether or not there's any other photography or inspection data that we need. Next chart. This is the second of the yellow boxes, and if I can't put both up at the same time, but if you kind of go back and forth between these detailed ones and the overall bottom of the orbiter chart, you can sort of remind yourself the position of these. So the one is kind of an area between the starboard landing gear door and the external tank door, and then the other one is actually on the main landing gear door, the starboard main landing gear door, and that's this one here. And then the next chart, this is actually an area that's on the elevon itself, and so it crosses a couple of different tiles, and then the very leading edge of it is actually the tile that's on what looks like the hinge line if you look in the bigger picture. So these are three areas that are an example of some areas where the team wants to do some more work, some more assessment. And as a normal part of our process, they will go do that. At this point, what we have said is that we don't have any reason for concern or alarm. As you know, we have a focused inspection placeholder in the timeline, and that would be on flight day 6, which is Saturday. So what we've done is we've asked the ops team to go to the next level of preparation in terms of ensuring that we don't do anything to preclude being able to do that focus inspection. If in fact the team comes back and says our analytical techniques were not able to clear one or more of these sites, then we'll want to go get some more detailed photography and imagery of these sites, and then we can go do that. So we're very much in the middle of this process. I wanted to show you today kind of the areas that we're still working on. Overall, the vehicle's pretty clean in terms of total number of damaged sites. And these were a couple of the ones that we're going to look at in more detail and going forward determine whether or not there's anything else we need to do. So we wrapped up with a discussion about the undock, the Soyuz undock plans. We will talk tomorrow morning in the Space Station Program Mission Management Team about, in some level of detail between the shuttle and the station programs and the supporting teams, we'll talk about what the plan is for the undock and getting the photography. We will then carry that discussion forward to the shuttle MMT tomorrow afternoon and give the broader shuttle team the benefit of weighing in on the plans there. And then we'll be prepared to go into Friday morning to the station program MMT again, where I believe that they are planning on doing the undock, their standard undock go-no-go that they would do for any departing vehicle. I believe they're planning on doing that on Friday. So we talked a little bit yesterday about the timeline for that with the respective MMTs, and I didn't have enough detail on it yet, and we do today. We know that that's the plan, and so we look forward to those discussions. So beyond that, the team is doing great. The crew on orbit is doing great. You can see that the vehicle performance is continuing to be very, very good, which helps us a lot in terms of being able to execute the mission. We're looking forward to the AMS activities tonight when the crew gets up. It'll start tonight actually, but it'll be in earnest in the wee hours of the morning tomorrow. So a lot of folks very excited about that, and we look forward to that. And another exciting and very productive day in orbit today, as I said. And so with that, I think that's all I have, Connie.
Okay. We'll start with questions here at the Johnson Space Center. Okay, come on.
Mark Carreau for Aviation Week. I just wanted to ask you about part of the AMS ops tomorrow. Is there any sort of thermal clock that is critical to the transfer on that piece of hardware, or could it stay longer on the arms if for some reason you had a difficulty?
Yeah, we have a clock, but I don't think that it's a situation where we have really credible scenarios that would cause us any concern with that. So we have the right actions in place if we should get into some kind of robotics contingency, but I think that's pretty unlikely.
Philip Sloss with NASASpaceflight.com. On the images that you showed us, what makes the three items that you were highlighting more of an interest or a priority in assessment? And then in the big picture of the orbiter belly, is it possible that damaged track was perhaps a common cause or caused from some common event?
Yeah, so on your first question, the individual sites, of course, the team will, they're very good at this, as you know, and they're very thorough and they're very disciplined, and we will stay very much within our processes and within ourselves for doing these assessments, so we don't want to get ahead of ourselves. So each one of these sites is unique in that the tiles are different geometry, they're different thickness, they're in different regions of heating, and so they're each very specific in terms of their capabilities, and they're specific in terms of the function of what it is that they need to protect from a thermal protection system. And so each damage area is unique also. It has different size, different overall length, width, and depth, and different volume, and all of those things play into the function of the tile, and if there's anything to be studied in terms of whether there's something of greater interest in one area than the next. So it involves looking at aerodynamically what we think will happen at each one of the sites, obviously thermodynamically what will happen at each one of the sites, and then the overall interaction of from one site to the next, what happens with the flow. And so it gets pretty involved. We take them individually, and then you have to take it as an overall system as well. These three areas are areas where generally there's a little more depth, we believe, preliminarily. There's a little more depth to the damage areas, and or they're in areas where we have a greater interest because of the thermal effects. And so, frankly, until we do some more analysis and until we get a little bit better fidelity on the photography data, we may change our mind on which site may be of greater interest than others. But at least initially, these are the three areas that we think we want to go do some more work on. I should mention that work will be done, probably in the next 24, 48 hours. And there's a lot of, there's some 3D analysis that will happen. We have experts in the photo labs. We'll do some analysis as well to try and help us with dimensions. The dimensional part of this is pretty important. And then the aero and thermal folks will do a lot more work to determine whether or not there's anything that they need more detail on any of their respective sites.
Gina Sinceri, ABC News. Couple questions. I know you keep a pretty good database of previous tile damage in areas like this. So can you put it in context with previous damage? And then what is the heating on reentry in that area?
Well, your first question, we do have a very thorough and complete database. It'd be premature for me to try to compare it because I don't think I know enough about any of these damage sites to be able to do that. But the experts will do that for us. That is, one of the good things about this process is we the team will bring in comparative analyses, comparative assessments, and we'll do, we'll leverage on our previous experience in previous areas that we've looked at. So I can't tell you sitting here today, oh, this was like, mission whatever on vehicle whatever. That would all be guesswork. And the heating is different too at different places along the surface of the vehicle at different points during entry. So it's in the thousands of degrees, and depending on which site you're talking about at what point during entry, it's going to change. So we'll talk more about that as well as we talk through each one of these areas through the assessments. Is what kind of heating do we see in these different areas, and those details will be forthcoming as well.
Clara Moskowitz with Space.com, and I'm just wondering if, given the unique history of the external tank that Endeavour launched with this time, if you're at all surprised that the vehicle is as clean as it does seem.
No, I'm not surprised. I talked a little bit yesterday about the performance of the external tank, and we did a lot of work on the tank, both actual touch labor and with some modifications as well as analytically. And putting it side by side with our other return to flight tanks. And so not surprised. The performance was outstanding on this tank by all accounts. We knew what areas we could expect, likelihood to have some foam losses from, and that's turning out to be the case. So I think it's pretty much, if anything, better than our expectation.
Okay, I know we have reporters on the phone bridge as well, so we'll go there next with Bill Harwood, please. Can you hear us, Bill Harwood?
Yeah, hey, Leroy, can y'all hear me okay?
Yes, we can.
Thanks. A couple of quick ones from me. Is there any sense of the timing on these? I mean, obviously the ET cam, there wasn't anything like this that was certainly obvious anyway. Just wondering if you had any sense of when in that sense this might have happened.
Not yet, Bill. We haven't been able to map anything that we're seeing in the ascent video or imagery to damaged sites. I mean, we'll work on that as a matter of course, because that's part of what we do in the process. But we haven't been able to do that yet.
Thanks. And in looking at the ding on the I guess it's the starboard landing gear door, is that right? It looked awfully similar to the one on 118 that you guys, that was near the door anyway, and that I guess coincidentally, Scott Kelly was the commander of. But you guys decided in that case it was okay to fly as is. I think it was right over a structural spar or something, gave you a bit of a thermal heat sink. Is there any special concern you can tell us about in terms of something directly on a landing gear door, thermally? Thanks.
Yeah, your recollection is good, Bill. We've had a few flights where we've had some areas that we looked at more closely. STS 118 was one of those, and in fact, one of the tiles. It's not one of the ones that we have in the yellow blocks on the graphic that I showed you, but one of the other ones is actually a tile that was also damaged on STS 118. Of course, it's a new tile, but it's the same tile location. So there are some similarities, and we do, as I was mentioning earlier, we do leverage off of our database. I don't know enough about the damage on the landing gear door yet to be able to talk specifically about anything beyond what the team has given us so far, Bill. So I will have some more detail. Obviously, we can talk about that as we go forward and determine exactly what the magnitude of the damage is, and see what the analysis shows us.
Okay, next on the line is Irene Klotz, please.
Hi, thanks very much. Irene Klotz with Reuters. Leroy, I had a few questions. The first is, I hope this doesn't just show that I'm totally ignorant and haven't been following things, but I thought that the change of command from ISS was rotating between American and Russian, and I think that this change of command is going from Russian to Russian, and I understand this is probably a question for Bill Gerstenmaier, but do you have any insight into why that is?
You're exactly right. That's a question for Gerst or for my friends in the space station program. So we'll but I'm sure Kylie and our station friends can get you an answer on that.
Okay, thanks. The other thing is, based at Kennedy, there's with every last, there's a big event. Last rollover, last hoisting, last everything, and I'm wondering if you all at Mission Control are getting a sense of wrapping things up with this on the shuttle program. And in conjunction with that, if you could maybe discuss a little bit about how important this mission is for the overall long-term viability of space station after shuttle retirement.
Okay, Irene. Well, as far as the last, what I would say about that is where Houston and Mission Control and that aspect of the shuttle program is concerned. If you were to go over there today and immerse yourself with those folks and be part of what they're doing day to day, during a mission when we're executing, you wouldn't know that there was anything like that going on. So it would be just as if you were going and sitting with them, 10 years ago during a shuttle mission. And it's one of the things that really needs to be heralded, I think, about this team across the entire program is that during this entire process, they have maintained a very high level of professionalism, integrity. Their dedication to the job has been unwavering. And we see this in all the organizations now, to include, the other centers, in particular at Kennedy and Marshall, as well as here. And so my sense is you can't really tell a difference, when we're going about doing the execution of the mission, in this case, a shuttle dock mission with the station team. The mission itself is very important, as you know, as we've, I think, chronicled leading up to this point. It's, long time coming. A lot of folks are really anticipating the activities that we're about to get into tonight and tomorrow morning with AMS. I think that's huge and very important for folks. And really, we ought to recognize the significance of that, just that part of the mission in and of itself. And overall, obviously, from the other activities that we're doing with the ELC, and in terms of transfer activities and the normal kind of work that we do on shuttle station dock missions, it is very important at this point in the station's life. And the next one will be very important in that regard also. So it's difficult to say, one is more important than the other because they're not created equal in most regards. And so I wouldn't want to get into that realm of things, but very important mission for the agency, certainly for us in the shuttle program. And as we've said now for the last couple of years, we're dedicated and determined to finish strong. And I think you see us doing that. We're doing everything we can to stand by that. And so far, I think this mission has been consistent with that theme. So important mission for us, and it's going very, very well.
Thanks, Leroy. The last question I had was about the 16-day mission. Is there any possibility of extending beyond that? Thank you.
Well, there's always a possibility, and we know that when we get on orbit, we try to take things from one day to the next, and we have a very good plan. The team has worked really hard on this plan. We can sort of plug and play these days, as I talked about yesterday a little bit, and the flight directors can give you more detail on that. So far, we're not looking at doing that, Irene, but we certainly have the capability to do that. It's within our experience base to do that. So between us and what the space station program needs are as we go through the mission, we'll take that one day at a time as we always do. And if we decide we want to talk about it, we'll do our normal assessment, we'll do our normal trades. And depending on what the reason for it would be, we'll have those discussions as we go forward.
Okay, next on the line is Todd Halverson.
Thanks. Todd Halverson of Florida Today with maybe a couple, but first of all, Leroy, I was wondering, I'm just kind of trying to gauge the significance of these towel dings. I mean, what in your judgment is a potential that these might cause the need for a focused inspection? And I'm wondering whether this is something that might require repairs or endanger the crew during reentry. I'm just trying to get a handle on the overall significance of these towel hits. Thanks.
Okay. Well, Todd, what I would say is, these are areas that we don't have enough data or analytical or photographic or otherwise. Yeah, we haven't done enough work yet to be able to determine whether or not there's any more information or assessment that we need on these areas. To include, first of all, focused inspection. So that's what we're in the throes of doing that work right now. And the team, we're going to stay within ourselves. We're going to stay within our processes. We have very tried and true and proven processes and techniques for doing all this work. I would tell you, as I said in the beginning, this is not cause for alarm. It's not cause for any concern. We know how to deal with these things in terms of how to assess them. We know that if we get to the point where we need some more data for our assessment, we have a plan for going and doing that. We know how to go and do that. It's in the timeline to be able to go and do that with focus inspection. And then to the other part of your question, I guess I don't really want to speculate, Todd. I don't have any reason to do that at this point. We've got some more work to do in these areas. It wouldn't be fair to the team that's working really hard on these assessments for me to do that, and I don't think there'd really be any value added in me doing that. I am not concerned, and myself and the team were certainly not alarmed by what we're seeing here. My confidence is derived in knowing that we have a highly skilled, very professional, very thorough team. We've been through these kind of things before. We understand the work that we need to go do, and we're very much in the midst of doing that work. And so we're going to take it one day at a time. We'll bring in the data as we're able to evaluate it through the MMT process and share that with you. And so you'll be right there in step with us in terms of knowing what I know. And I don't want to speculate on the other part of your question for today.
Okay, I appreciate that. I just wanted to ask you one other thing, and that is in regard to the final four EVAs of the shuttle program. I can remember back in the early 1990s, the mid-1990s, when Greg Harbaugh was the chief of the EVA office. There was all this talk about the wall of EVA and how difficult it was going to be to assemble the International Space Station. And I was wondering if you could describe for us, what exactly that wall looked like then, and whether you have any surprise at all that things have come off as slickly as they have to date. Thanks.
Yeah, that's an excellent question, and it's something that I personally have pondered quite a bit going back to before return to flight. Just a little story about that. I was down in Florida one time during that return to flight process, and we went over into the SSPF where at the time we had all of the space station hardware, these various elements and nodes and large pieces of the space station that today are on orbit. And they have sort of a catwalk area that you can walk along where you can have a really good vantage point of the floor and of the SSPF, which at the time was literally full of space station hardware in all these various pieces. And it really gave me pause thinking about, because I'd been very much involved and in the throes of the return to flight process, and the things that we were doing with the shuttle to get ourselves ready to go fly. And it really made me stop and think about the task that we had in front of us, because every one of those pieces of hardware, in most cases, almost every one, several of them anyway, we say it that way, it's a fair way to say it, involve one or more spacewalks to be able to assemble and check out and configure to get to the point with the space station as we know it today. And it seemed to me at the time to be an incredibly daunting task. And so I thought a lot about that then, and since then, as we've kind of just done one mission at a time, we've worked through one spacewalk at a time. Our space station friends have done an unbelievable job working with our teams and choreographing all these things, and working every mission, every spacewalk of every mission, every potential contingency to the level of detail that just makes your eyes water. And then they kind of just all, for the most part, came off, not literally, but quite nearly almost without a hitch. And spacewalking is one of the most challenging things that we do, and it's one of the areas that we put a lot of emphasis on. And so I had a lot of thoughts about that going into the return to flight missions, leading up to each one of them as we clicked off each mission, leading up to where we are today, Todd. And I wouldn't say, surprise is not the word, but certainly it makes you think about what has been accomplished and the potential that was there for us to have some challenges and some things to overcome that we were fortunate to not have. And I say fortunate, but really that's the result of a lot of hard work by a lot of people in terms of building the hardware, checking it out, processing it, getting ready to go. The teams that built the procedures and the techniques and spent all the time in the pool and in the control center and on and on and on and on and on. So much work has gone into each one of those missions to make sure that we could handle any contingencies if they came up. And we just had a lot of good fortune, and the hardware has really performed well. And we've tried to take lessons learned from earlier times in both programs, really shuttle and station, and implement a lot of those things as we set out to construct the station in earnest, because these were some pretty significant tasks that we had to do. So pretty amazing overall. When you look at what we have on orbit today, we've said it over and over again, you kind of have to pinch yourself. And it's something for the team to be really, really proud of. And certainly the station is a huge part of the shuttle's legacy.
I believe that was all online, so are there any follow-ups here?
Mark Carreau for Aviation Week. I just wonder if any thought or discussion was given to using any of the space station spacewalk opportunities to do any look at the underside tile on Endeavour.
Yeah, we're not there. That's way on down the line from where we are right now, if we had determined that we need to do anything additional or not. So that's, if we're on step 10 of 1,000, that's like 700 something. And so we're just not to that point, quite honestly, Mark. But the team is, this team as well as I do, they're very creative. And we know we have a lot of capability between what the shuttle offers to itself for these kind of things, as well as what we have when we're at space station. And so we enjoy a lot of really great capability in that regard, and we'll leverage whatever we would need. But I don't anticipate anything like that in terms of what we're looking at here.
Any more follow-ups? Sure.
Clara Moskowitz again for Space.com, and I'm just wondering about the robotics work tomorrow to install the AMS, and if you could speak to kind of big picture, just how difficult, challenging, and how much risk is involved in those robotic operations.
Okay. Well, I don't know that it's the most challenging robotics operations we've ever done. You know, the team goes to a lot of effort to make sure that when we choreograph these things, it's done in a way that we have off ramps and we have places where we can stop and evaluate. And so, from a contingency standpoint, you know, there's no stone unturned in that regard. It's certainly a challenging operation. Anytime you're moving around, you know, large masses like this that have the kind of dimensions that the AMS have, and you're moving it from the shuttle payload bay, the cargo bay, to a specific place, where then you need to hand it off and then move it to a specific place on the space station. You know, that there's a number of challenges involved with that. The different camera views that you need for the robotics operators, both on the shuttle and the station. So it's pretty involved, pretty complex. I wouldn't want to venture to say it's the most complicated or most complex or most difficult or most risky. They're all kind of unique in that regard, and this one will be very exciting for the team to get this work done tomorrow. And I know there's a lot of folks around the world that are pretty interested in what we're doing here. So we're really looking forward to it.
Any more follow-up? Seeing none, we'll go ahead and wrap up the briefing for this afternoon. Coming up on NASA television, we will start airing the Flight Day highlights from Flight Day 3. Those videos will begin at the top of the hour during the crew sleep shift, starting at 4 p.m. Central Time. And then the shuttle crew is scheduled to awaken at 1:01 a.m. Central Time and start that robotic work to install the alpha magnetic spectrometer 2, leading up to the station robotic arm installing it about 2:41 a.m. Central Time. That operation will begin. Thank you for joining us.